Okay, so NC and Abigail, when you see this, a question like this, um, there are two shapes involved. You will see a cylinder involved, and you will also see that there's a cone involved. So you got to read very carefully the volume. Is it whether for the cylinder or is it whether for the cone? Okay, so some students, they don't read, so they end up like getting the wrong volume. So in our situation, our volume is for the cylinder. That's why straight away at part 2, I already know that if I need to write down an expression for the volume, it will be pi r square h. Okay, so if you look at it, right, cylinder is pi r square h. But in part 2, our volume is in terms of r. But my formula got a h. So I need to get rid of this h. So in this question, the way to get rid of this h is to prove this part. So in fact, right, I can just insert my h from the first part. So that will be the answer already. But how exactly do I get the h in part 1? It is actually a similar triangle. But the whole question is not going to tell you. You never see the whole question saying, oh, use similar triangle. So you yourself got to detect the similar triangle. So where is the similar triangle, right? I'm going to show you. So the similar triangle is here. So there's a small one. Okay. And the whole height is 50. So this part is 50 minus h. So I got a small little triangle. And I also got a very big triangle here. So these are the two that will be helping in my similar triangle. So these are the two similar triangles. So how am I going to present part 1? I'm going to say I'm going to use similar triangle. So using similar triangle, you do not need to prove. You just have to say that you are using similar triangles. So you will compare the ratio. So for example, you can compare the height ratio versus the radius ratio. Then you try to cross multiply. You try to cross multiply. So you will get the 50 minus 2r. So the 50 minus 2r is obtained from similar triangle. Okay, so what I did was I compared the height ratio versus the radius ratio. Of course, you can also be comparing the height over radius versus the height over radius, whichever that you feel is easier. So it doesn't matter which ratio you compare. So if you cross multiply from here, you also get the same h. So the critical thing will be you need to use similar triangle, and no question will mention this. So no question will mention this. So if let's say you fail to show the first part, you can just carry on with the second part. But you must know that it's a cylinder. Then after that, we are going to get the maximum volume by doing a dV dr equal to 0. By doing a dV dr equal to 0, Okay, so you need to differentiate, right? So some students, right, they will tell me, oh, so in this case, I'm going to use my product rule. So if you are thinking of using the product rule, you're not wrong. But in this case, because I can open up the bracket, so I actually prefer to open up the bracket. Then I do a differentiate. Okay, so to apply the idea of bit volume is maximum, the concept will be dVdr equal to 0. But your dVdr will come from your technique of differentiation. So in this case, there are two options, either a product rule, but I don't want to do a product rule because I can open up the bracket. So I just do a normal bring down power minus power. So I'm going to make it equal to 0. And I can bring it, okay, when I equal to 0 already, I can divide by pi, and then I can take out common factor, and then you solve for your R. So you will be able to solve. So your R is 50/3. The pi is a constant. Remember, pi is a constant. So I can divide by pi on both sides. If it's the R, I cannot divide. So the pi is a constant. So in a way, I divide by pi on both sides. Okay, it's a constant, so you can do that. If it's not a constant, we don't do that. You realize I didn't divide by R because R is not a constant. Okay, so I answer the question, I gotten the R. So if I want to find the maximum volume, I return my R to the volume formula. And then you punch calculator. So you may need to round it off to 3 SF. So the general idea will still be the same. So it's actually the same idea like example 1 to 4. You need to differentiate the item that you want it to be maximum or minimum. However, in this case, right, there is a similar triangle. And this similar triangle may not be mentioned to you. Throughout the whole question, they never say similar triangle. So when you go and do differentiation test or what, you need to be aware that there will, in some point of time, you may need to use similar triangle. It can appear here or it can appear under rate of change. I think in rate of change, I should have shown you one with similar triangle. If I didn't, you got to let me know. Okay, so similar triangle is needed in some part of differentiation. Not just restricted to here, it can be under rate of change. So you must be aware that there's such a thing, or else you can't do. Okay, so if let's say you can't do part 1 through similar triangle, part 1 can be used in part 2. And then we still apply the same concept. And in this question, they never tell us to prove maximum minimum. Okay, so they never tell us to prove maximum minimum. So actually I won't prove. But if you want to, if time permit, you can actually play safe. Play safe and test for maximum and minimum using the second derivative or even the first derivative. Okay, so that is the example using similar triangle.